Hello class, this is Miss Riggins. So today we're going to talk about a very important concept in geometry called distance. And as you all may know, distance is a unit of measurement to tell you how far apart two objects are. Now if I wanted to determine how far apart the blue and the black dot are, I can take a ruler and measure it and tell you based off the units of measurement of the ruler how far apart they are. But since this is high school geometry, we're going to take it a little bit further. What if we don't have a ruler? Will you still be able to determine the distance between these 2 points? And the answer is, of course, yes. The easiest way to determine that is to type a number line and place it so that the points lie on the number line. So let's say here's my number line. I'm going to place it so that my points lie on the number line. And even though you can place any of the starting points anywhere on the number line, people like to place one point on 0 and the other point somewhere else. So if I place this number line where the black point is on 0, I can see that the distance apart from the black point, the blue point, is around a little bit over 6 units apart. And I can only say units because I don't know if this number line is in centimeters, inches, or whatever the deal may be. Now, if I were to go over and place the black point at -4, what would be the distance that the blue line is away from the black line? If you said a little over 6, you're absolutely correct, because all we do is we count the number of units from the black to the blue. 1, 2, 3, 4, 5, 6. If we don't want to sit there and count with our fingers, we can take a look at the coordinates and figure out that distance as well here. So one thing you can say, if I'm going from the -4 floor to past the second floor, how many floors up on the elevator am I going? Well, if I'm at the -4 floor and then I end up at the second floor, I've gone up 6 floors. So the thing that I want you to point out, though, that is important to note, is that the distance that the blue point is away from the black point is the same distance that the black point is away from the blue point. Even though if I started here at the blue point, I'd still be going 6 away to get to the black point. I'd be going in the negative direction. But one thing we must always remember about distance is never a negative number. So the distance between the black and the blue point is always the same value, no matter if you're starting from the black and going to the blue, or going from the blue and going to the black. And that's important to note. So how do you come up with a formula to represent this as well? Well, the formula that we can use to come up with this is called the absolute value formula. So let's take a look at that, and that's it. Here on page 41 of our notes, we see that the distance between 2 points is the absolute value of the difference of the coordinates of A and B. So in this case, it looks something like this, where x1 and x2 are the positions of the points A and B. So let's take a look at this and apply it to our previous problem. So as you can see, no matter where the coordinates are of the blue and black points, using that same formula, I still get out a value of around 6.2, being the distance between. No matter if I start as the blue point being x1, 2, and the black point being x2 and the blue point being x1, or vice versa, I still get the same distance. So that's the easy case. We like it when they're on a number line because all we have to do is either count the difference, or we have to use this formula of taking the difference of the two coordinate points. But what if they're not on the same number line? How are we going to handle that? Now, I know some of you can say, oh, well, that's easy. Just take a number line and just rotate it so that it goes through both points. And although that is a very ingenious idea, it's really not something that we always have at our disposal. But what we do have is something that you learn in middle school to help us figure this out. So let's take a look at the distance between the blue and the red line. And as you can see, it's not on a horizontal or vertical number line, but let's say I put a grid between the two. Now I can see there are 2 positions. And if I were to take, let's say, a slanted line, really the distance between these 2 points is the length of this little line segment right here. Well, unfortunately, this line segment is not a line or a number line, and it's not dashed in units. So we still don't know the length of this number line, but we can use something that we've learned about in middle school to be able to determine how far apart or how long this line segment is. And so how you do that is something, if you remember, called Pythagorean theorem. Let's say this slanted piece is really the hypotenuse of a right triangle. And to be able to figure out the distance of this slanted piece, all we have to do is use Pythagorean theorem and the equation that says a squared plus b squared equals c squared. But what is a and what is b? Well, let's take a look. Let's say I were to take this blue point. Then really a is only the distance between the blue point and the green point, and they do lie on a number line axis. So if that's the case, we can still use our same formula that we found on page 2, but this time we're going to do a little bit differently. So since we have these number lines now, we can say that A is really the distance between this blue point and the green point. I'm going to call it G1 on a number line. And B, for this right triangle, is really the distance between this green point and the blue point on this number line. And so to be able to figure out what the length of the hypotenuse is, we're going to take the square root of the square of this A and the square of this B so that we can come up with our answer. So let's see what happens when we put actual numbers in it by placing coordinate grid on it. So if I place the coordinates of the point of the 2 points that I originally started with, this is -7, 1, and this is -3, -5, and I plug this in. How far apart are this green and this A? Well, this green point is at 1 on the y-axis, and this blue is at -5 on the y-axis. So when we do 1 minus -5, we get 6, or -5 minus 1, we get -6. And over here, we take a look at how far apart these are on the x-axis. Well, this blue coordinate, is at -7 on the x-axis, and this green coordinate is at -3 on the x-axis. So when I take a look at their difference, -7 minus -3 is -4. So all I need to do now is plug it into the formula. And I know some of you are saying, but wait, distance is never negative. How is that you don't get negative? Well, remember we're going to square it. So whether we put in -4 for A or +4, when we square it, we're still going to get 16. And whether we put in 6 for B or -6 for B, we're still going to get +36. When I finish calculating this, I get C is equal to the square root of 52. Because C squared was 52, so therefore C is equal to the square root of 52, which is between 7 and 8. So let's take a look at the formula for the distance between 2 points that are not on the same horizontal or vertical number line. Okay, this is the distance formula. You need to memorize this, get a good understanding of it. This is part of your notes, so it's of grave importance. This is the formula, and I want to point it over. It's going to be clear in your notes. But let A and B be any coordinates, any points, and the distance between these are exactly like what we did. The square root of the distance squared of the x values and the distance squared of the difference squared of the y values. And all that comes from the Pythagorean theorem, okay? One last thing I want to mention. We've been talking about distance between points, but right now I want to discuss the distance between a point and a line. How far apart are this point and the line? And I know most of you will say, well, I can easily just take a line segment like we did earlier and just measure the distance from the point to the line. But then my question is, which line segment are you going to pick? There's a lot of different line segments that start off from the point -7, 1 and go toward the line. Which one do you select? And are they of the same length? Well, as you can see here, it's impossible for them all to be the same length. So since distance can't be changing for the same two figures, we can only pick one distance. And which distance do we pick? We pick always the shortest distance. So the shortest distance, and the shortest distance, as we can see, is this red line. Do you know what the relationship is between this red line segment and this black line? What's the relationship between these lines? Well, if you say that the shortest distance is the perpendicular distance, you are absolutely correct. The shortest distance is the perpendicular distance. And we'll find more about that out in class. Okay, the end.